So we're doing a video about our simple game which is called the Blox. My name is Pamela Ramos and I have my partners with me.
My name is Mateo.
Hi, I'm Katrina, Lomotan.
Program.
The Blox.
So me and my group mates have made a game called Blox, and this game is basically inspired on the existing game found on the internet, which is Bloxorz. It consists of a map wherein the block will traverse and a golden tile. It also consists of a 3D block which has 6 sides, and each side of the block will touch the path per move. Also, the group had made a game inspired by Bloxorz using assembly language. The original game, compared to what we have made, contains a hole in the middle which we will shoot the block in there upwards, but compared to us, we have implemented a gold tile. So this is what the users will see when they first open the program. They can start the game, or they can view the high scores or exit the program. So here is the mechanics. To move and efficiently orient the blocks, the users can use the keyboard arrow keys, or they can use the left click mouse button to the immediate vicinity of the block and translate it to the movement. So to win the game, the gold tile should be reached in upwards position of the block, and the scoring is dependent in with the total points left and time elapsed. There you go. There will be a limit of 10 moves per user. So, and each stage of the block contains a map, and a map is composed of tiles or squares in which the block will traverse through, given that it fits. By making the block possible to fit, the golden tile, while standing up, finishes up the stage.
So for the abstract, this design of experiment was made for a requirement in the course COE119L. The game was programmed using assembly language that requires DOSBox to implement and run the compiled assembly codes. All the necessary skills and knowledge learned in this course in making the project. The game mainly used the mouse and keyboard arrow keys as point-and-click medium. So for introduction, high-level languages such as C# offer a great tool to create a game in GUI form. Assembly language, on the other hand, is a low-level language. It is almost in the form of machine language. The only difference between assembly language and machine language is that assembly language enables the programmers to use names instead of numbers. Despite that, assembly language offers a way to represent graphics and allows access to interrupts that send signals to process instructions. Could these assembly language features enable us to create a game that would incorporate all of these features in a game where the player must be provided with enough visuals and controls that would allow the player to engage in a computer game and would be able to fulfill the rules of the game? The assembly language is a powerful language, and when used accordingly could garner good results. So for the statement of the problem, the group had made a puzzle game in which different interrupts could be used. The game is composed of tiles, a golden tile and brown tiles. The 3D block will traverse through the 2D tiles, and the block needs to step on the golden tile, positioning upwards to win the stage. There are 5 stages to finish the game, and also high scores will be implemented. So for our objectives, to apply the necessary skills and knowledge learned in the laboratory, and also to create a functioning Blox game using assembly programming language. So for our scope and the limitations, the programming language that is used is assembly language. Several interrupts will be used and demonstrated using the DOSBox, such as video and mouse interrupts. The game can only be played by a single user. The user will be using the mouse to click the necessary movements to let the block move. Also, the user can use the arrow keys on the keyboard to make the block traverse through the tiles. So for our methodology, we are going to use a low-level language programming such as the assembly language, and the group was able to create a puzzle game. By doing this, the writing of the code was more efficient and the processing of the code was faster and removes unnecessary commands in the program.
So for the instructions, the user can control the movement of the block by either using the mouse or using the arrow keys of the keyboard. There will be a time limit, and also the number of moves will be limited to just 99 per player. This is examples for the as you can see, these are the stages 1, 2, 3, 4, 5, and this is the score. This is the sample layout of the stage 1. This block must be upright to this place this yellow box type. Next is the stage 2 layout. The stage 3 layout. Stage 4 layout. And stage 5 layout.
I'm going to talk about the process flowchart, our project. Let's start. Go to menu. Play game. If yes, load map. And you're going to level 1. After level 1, read arrow key via interrupt 16H. Move the block based on the reading from interrupt 16H. So the question is, does the puzzle solve? If yes, high score. Then you're going back to load map for the level 2. After level 2, you're going to back read arrow key via interrupt 16H. Move the block based on the reading from interrupt 16H. Does the puzzle solve? Yes, high score again. Then we could load the map for level 3. Level 3, read arrow key via interrupt 16H. Move the block based on the reading from interrupt 16H. Does the puzzle solve? If yes, high score again. Load map for level 4 and level. After that, if the puzzle is not solved, the score equal to 0. If yes, we're going back again. Start. Does time equal to 0? Start again. Now going to start the level 1. So looking. So if your high score is yes, show the high score to text file and write a name and score to the text file. Later I'm going to show you the example. And if you want to see your score recorded, then go back to menu and mix it. You don't turn it anymore. The aim of the game is to get the block to fall into the square hole, which is the goal or the yellow one, at the end of each stage. There are 5 stages to complete.
Let's start. Down arrow key, up arrow key, and right arrow key. Let's go back. Left arrow key. And then let's start. Enter your username. This is the level 1. Solving the level 1. to the next stage. For the next round, we're gonna use the left click mouse.
Fairness, mahirap. Hirap i-solve nito ah. Ano to? Lo! Kanina pag mapasok, hindi ko mamalis eh. Hindi na ako nasa Nasolve na ba to?
As you can see, your points is your movements. So, you lose it all, you're gonna repeat it all over.
Bastos naman yun. Yan eh. Magkagawa na. Natakat ko yun. Stage 1. Yay! Lupe. Medyo nakakabisado ko na. Ito na po mga kapa. Ibagay. Yun lang, nakalimutan ko dito. Ay, password ka? Ilang? Meron na password namin dito. Ano ba to? Mateo 9681. Small letter lang ah. Mateo 9681. 9681. Sa kapatid dito? Hindi. Niyamit yung reader ng ano. Agile.
Hi, I'm gonna show you the codes of our game called the Blox game. So, small, stop 1 to 8, locals, scores, anonymous, duplicate. So, here are the names of the players that will be going to the data. And here is the scores of the players who played, the highest scores. As point name, score are unavailable. So here's the scores are unavailable. High score, note scores, text is missing, specs. Score reset, username. So you're gonna input your username. If you lost the game, enter a key, final score. Then there's instructions about the Blox instructions. Blox is a 3D puzzle game that involves a rectangular block to pick. So it will be shown there, the game. So here are those I'm going to show. File stream, path TB scores that text. So here's the data going. Full stream, file stream, scores that text 100. There you go. Pixel right. This is the levels. This is the special coordinates and row DW. Stars current row, stars current column, stars the word itself, stars the current orientation. This one, it checks if it is valid move. Enable DW. Games essential sentinel value bit 0. Set if you quit, if you win, if losing, set if start screen, set if enter, set if scores, that text is unavailable, set if other file error, set if high score. So here's the test coordinates for mouse. So this is the code for using the mouse or the cursor. SMDW set to if x equals to 0 is neg. Reference store real mouse or coordinates. Scoring. This is what you call scoring. Scoring. Times DW, score 1, 2, 3, set points, loop variables. This is the settings. Dark, yeah, of course it will be black. Main code. Here it is, data. Start main, call start, call init score, show score, high score procedures. So this how you set high score procedures. Call parse, exit score, level start. And then next. Draw blocks up, forward, draw blocks down, forward, down, back. Function, it calls it out. Call display, move. Here are the begin game. If you begin game, level, select level. Of course, it will be level 1 on default. Call. Check if quit. So if end blocks, quit blocks. So this is the function of init score. It stores the high scores, the scores only. I mean, set init or parse and the master score procedure. This is the procedure where you can solve the score. And then this is the do not compute score if user. It will not compute the score if you use. Display default out control quit master. So this is it calculate total scores, calculates the actual scores from time and points remaining. Final score. Open and read and close scores. Write buff into scores.txt. Here it prints the score screen. Too much. 4, 3, level 3, 4, 5. Auto scores. So it prints scores 2, score 1, score 2, score 3. Expect scores. Score in hex. This checks if it is high score. Comparing. This part. Change high score. Parses the score from buffer. Address where the string collected from the file streaming is stored. Encodes the scores from individual variables expects. Buff is equals to address to write the variables in preparation for file streaming. Start screen procedure. Start screen menu. Here, start screen display various graphics. Called pixel. Spec. Next. Scores and call graphics again. This is the keyboard movement using the arrow keys. Mouse movement, or you can use your cursor by moving it and clicking where it should be going. decrement score, the time, and the movement quantity, initialize level values. Master movement procedure with inbuilt time system. So there's an inbuilt time system here to stop timer. If not, check if quit. Loops until the current second is not equal to the last, and reach. Like that. We put some of the comments here. This code here is the comparison to exit the loop and perform tick. And the div VL. AH contains seconds, AL contains minutes. And SHR, AX, take care of seconds first. AM, seconds converted to BCD seconds. And AX00FFH, take care of minutes. AM, seconds converted to BCD seconds. So here, code for display message, expects string to write, attribute, then coordinate. This one clears the screen, moves the blocks location, CMP is, so MOV, move 1, checks if it is valid, move, if not, exit. This code sets the block location, expect current block's orientation, expect movement input. New block row, new block column, new block orientation, set if valid. If not carry, then even move. So moves, move 1, move 2, move 3, move 4, 5, 6, 7, 8, 9, till 10. This check title type 2 row, check title type 3 row. This one resets field. So here are the comments, you can read it loud by yourself. JME special. So reset fields, move the row value to counter. In CX, increment the counter to use on loop, move the address and current level array to DX. This one. Move SIDX to be transferred into the source index. Loads SW. In usage for loads W that will store the array element in AX. CMPCX5 compares the counter to be less or equal to 5. Number of words to be pushed. JG continue loop, if not continue loading. Loop find row, loop will stop with the stack loaded with 5 words. Pop AX, pop stack, first word does not need searching. Move AX CRTR row, reset current tile first. Restores word, pop should perform 4 times. Store to CRT word, WRD. Moves current column to BX. Find call loops 1 time. Find call loops 2 times. Find call loops 1 time. Find call loops 2 times. Here it push AX the row iterator. Here it determines through row value. Load level expects address of level array, row number of gold tile, row number of gold tile. Compute coordinates, expects AX is equals to row, BX equals to call, X coordinates, Y coordinates. Row pixel coordinates, vertical loop, horizontal loop, so according there. Draw level row string, row value. Row field tile, AX is equals to X coordinates, Y coordinates for BX, base color for DH, DL for accent color. Procedure compare DH and DL. If true, inside the tile is not drawn. Draw blocks. Up. X coordinates, blah blah blah. Draw border. Draw color 1. Draw 2. Draw 3. Draw blocks. Down backward. So this is the code. The colors. Color 3. This is the forward, down forward blocks. Here it is, the code of our game.
Hi, I'm... It's okay, so...
Next is the stage 2.
Ay, sorry. Sorry.
Ay, sorry.